Okay, I think we should get going. Good evening, everybody, and welcome to the next Engineering Geology Society's talk, EGGS talk. We have got the wonderful engineering working group that have been looking at the offshore site characterisation. And that team is led by Chris, who I can see on my screen front and centre. Hopefully you all can too. He'll introduce himself and the team and that are going to be talking alongside him. If you're coming into the meeting, please try and if you're we haven't got the ability to mute everyone, so if you could please try and remember to mute yourself. That button is on the bottom left of your screen. We are inviting questions to be written into the chat pane. If you can't see the chat pane on the right hand side or anywhere on your screen, if you were to open up that ribbon up the bottom where you can mute yourself, slap bang in the middle is a chat button, and that would open it up, and then ensure that you've got the message set up to go to everyone, and then hopefully if it's a quick question, somebody from the working group will try and answer it as we're going along. Otherwise, if it's a substantial question, we're going to be having questions and answers and just a general conversation at the end. So but drop them in as you kind of feel you need. Doesn't need to be saved until the end. This meeting is going to be recorded, not by me because the settings are stressful today. So I'm going to invite Mike to start recording, if he would, and I will hand over to Chris, if that's okay.
No, I'm tempted to press the button, but it does not give me permission, I'm afraid.
Okay.
Stop it. Okay, Chris, you record it yourself.
Sorry. Same for me. So I think we'll have to do unrecorded for this, which apologies.
Can you not do it now? Is it not?
No, it's saying I need to have host permission to be able to record it. So
if anybody has got host permissions for this meeting, could you please record it? Otherwise, I don't think we're going to have a recording. How strange that the settings have gone for everyone else that had them previously. Okay, well we'll get started anyway.
Yeah, I think we'll have to crack on. But brilliant. No, thanks for the introduction, Steph. That's great. Can I just check? Can everyone hear me and see the screen? Okay. Perhaps if Steph can give me a thumbs up, that'd be
perfect. Yeah.
Yeah, excellent. Thank you. Yeah, good evening, everyone. It's a great pleasure to be here talking to the engineering group. Yeah, so my name is Chris Martin, I'm Director at ARAP, but very much talking tonight on behalf of the engineering group working party. So we're basically going to give you a presentation just talking you through the latest status update for the working party. Title here is the Offshore Site Characterisation, and it's Engineering Geology, Geomorphology and Geohazards. So I'm going to kick off. I'm going to hand over to Mike Clare, who's going to present some of the middle section, and then I'll close. But it's very much presenting on behalf of the working party. So I know a number of the people on the call tonight. So we've got Gareth, Jim, Roger and Lorraine from the working party. They may help to field some questions at the end. We're very keen to get some feedback from everyone that's on the call, either through this forum today or any queries, just drop us a line afterwards. Yeah, hopefully we'll as Steph said, we'll pick up any clarifications as we go through, or we'll aim to, but we'll have a good session of Q&A at the end, will be the plan. Right. So on the presentation, basically what I'm going to do initially, just sort of set the scene. I appreciate not everyone is aware what the Geological Society and the Engineering Group Working Party is all about. So just a bit of a scene setting as to where we've come from and why we set up. We're going to talk about the Offshore Working Party. We're about 3 years in now. We're drawing towards the end. Hopefully, we're hoping to complete by the end of this year, and hopefully be published in next year. And we'll give you an update on where we're at. And then a bit of a plug for the follow-on Working Party, which is on the nearshore and coastal. That's just starting out. So the plan was to close out the offshore and to start up with the nearshore and coastal. So that's really its infancy, and we're going to be presenting next month to the engineering group on the nearshore and coastal steering group. So that's the plan for today. Great. So just a bit of background as to what we're trying to achieve with the working parties and the engineering group. So working parties in general, they're convened by the engineering group as sort of technical committees to address sort of specific technical themes of interest to current practice. So for practitioners, they generally lead to a publication. That's an engineering group special publication, or SPE, which is published by the Geological Society Publishing House. Generally, the engineering group special publications are extremely popular. They're a good revenue stream for the GeoSocs. They're very keen and very supportive of our activities because they are intended for practitioners. Therefore, they have a very good uptake of both hard copy reports through the bookshop, but also more recently moved to electronic versions, and that sort of hybrid model that you can obviously still buy a hard copy report, but you have the option to download the full volumes and or specific chapters. So that's what the publications are trying to produce. They're normally convened by the engineering group, so we report back to the engineering group. But proposals are sought from many sources. So people out there have got ideas about certain themes they would like to see addressed by the engineering group, then please do drop us a line. And then just a bit of just sort of housekeeping really around how they work. So the forerunner to a working party is a steering group. These are basically just set up to test the water, develop a business case for a follow-on working party. So I'll talk you through about the steering group that initiated this working party and the coastal and nearshore as well. But they basically develop a publication plan, which is then submitted to the Geological Society Publishing House, that they are happy to have it as a publication. They are endorsed by the engineering group, that they would support it from a technical perspective. And they need endorsement from the wider community through, so from you guys essentially, to make sure you're supportive and you have the opportunity to endorse and or challenge the working party. And obviously then for tonight, we're obviously keen to get that wider engagement with the working party. So that's part of the aim of tonight's call, is to bring you up to speed on what we're planning, what the approach is, and what the final publication will look like. So that you have the opportunity to obviously to endorse it, to challenge it, to seek feedback from as wider an audience as possible. Moving on, it's a very long list, so I'm not expecting you to read this, but just to talk about the various working part or special publications that have been issued. I think we're up at 29 at the moment. Now, a number of these are sort of the black ones in the early years are very much sort of conference proceedings, so they were published as special publications. And then the ones that are shown in blue here are working parties. So they are sort of technical committees that are brought together to develop industry best practice guidance on a whole range of topics, including stone, aggregates, geophysics, clay, and then more recently hot deserts, glacial and periglacial, and geohazards. So a range of different approaches there. Just moving on, and then the more recent one that's very close to my heart, this was really the sort of forerunner to the offshore, was the glacial and periglacial special publication. So both Jim Griffiths and myself were heavily involved with this one, and it was this that sort of spawned the next generation, which I'll talk to. So in terms of how they're run, as part of a closing activity of any working party, there's basically a requirement that they should provide recommendations for future working parties. So as we were closing out the periglacial and glacial engineering working party, I'm trying to think when it was now, 5 or 6 years ago, we came together and thought it'd be nice to carry on that environment specific theme. So we had previously the tropical, the deserts, the glacial, the periglacial, to think about other extreme environments where engineering geologists find themselves working in. So we came up with 4 topics essentially, which was offshore, coastal and nearshore, fluvial and groundwater. So looking at the engineering geology of those 4 aspects. 2 were taken forward by the engineering groups, are slightly different. You'll see here groundwater. So that is an ongoing working party that's nearing completion, and that should be published either late this year or early next year. And then a second one that the engineering group felt strongly around was around artificial ground or made ground. That ran for a few years. It essentially put on hold, and it seems to be morphing its way more from artificial ground into a weathering, but that's in its very early stages at the moment. But we started the Offshore Engineering Geology, Geomorphology and Geohazards steering group initially. That was launched in 2017. We ran for about 6 months. a bit of a hiatus while we sorted out funding and funding approaches. There was, yeah, I won't go into detail of that now, but we started in anger in April 2019, so just coming up for 3 years ago. And the aim is that we're aiming to complete the majority of the draft manuscript by the end of this year. We've completed our first chapter, that's Roger Moore's chapter, it is done. That's been internally reviewed and externally peer reviewed. And then we've got a number of other chapters which are close behind. And then there's quite a lot of sort of dotting the I's and crossing the T's and driving that consistency across the publication. So realistically, we're talking about 2023 to get that published and to have the hard copies out there. But we'll keep in touch via the engineering group and give you any updates on that as it progresses. So last year, as we started to move towards closing out the offshore working party and sort of that, you know, the end goal of the science, we decided to pick off the coastal and nearshore as very much a sort of sister volume, that they would go hand in hand, sort of complementary reports. So adopting a very similar approach. There's a nominal water depth split between the two publications, which we felt we couldn't cover all of the offshore, coastal, nearshore, and the very near onshore in a single volume. So we decided to split it into 2 volumes. And I'll come on to talk about that in a bit. And we're reporting back next month on the coastal and nearshore. The steering group is now essentially complete, and we're looking to move to a working party after wider endorsement in the middle of this year. And then just the link at the bottom there, that all of this is available on the engineering group website. So then moving on to the offshore specifically and where we're at. So just a bit of context as to why this is important. Obviously, the offshore environment, it represents about 70% of the Earth's surface, so a very significant area of the globe is covered by water, but very poorly investigated. Essentially, they say that, you know, the surface of the moon is better understood than the world's oceans. So there is a lot of research being undertaken, the mapping projects globally being undertaken, but it is obviously a very risky environment to be working in. Traditionally, it's been the domain of the hydrocarbons industry that have done a lot of the offshore work and really set the scene. That's been developed more recently into offshore renewables and other aspects as well, like interconnector cables and telecommunications cables, and that are all pass through the offshore environment. So it's how do we characterize the ground, you know, what the risk management approaches that we should be adopting through the whole life cycle of our engineering projects. And essentially what we're trying to do, we're trying to bring together that whole wealth of academic, industrial, you know, private, public sector experience together into a single volume for the first time, and to provide consistent approaches. So that's the context of the scene. What we did as part of the steering group was to develop in terms of reference, which, if you like, are like the boundary conditions of what we are going to cover through the working party report, and also importantly what we're not going to cover. So what are we aiming to achieve? Essentially developing the sort of high-level business case. What are the objectives of the working party? So essentially what we're looking to do is to develop best practice guidance on development and application of offshore ground models for a range of engineering, geological and geotechnical practitioners. I think I mentioned before, you know, historically a lot of work's been done in the hydrocarbon sector, but recognizing the very different approaches and very different structures being built by the renewables industry. I'll probably just add, actually, over the last 5 years, in the course of the working party, that dynamic has changed massively. Obviously, there's been a lot of external drivers through COVID and all sorts of external factors. Really, the climate change agenda has really changed quite dramatically over the last 5 years. And we're really seeing the offshore renewables market sort of dominating this field, with the hydrocarbon industry really in its sort of dawn years, as it were, but trying to capture all that wealth of experience in a single volume. So that is part of the driver for the working party. In terms of geologically, what are we trying to cover? We're very much looking at what we call the shallow geology and geomorphology, which is significant ground engineering activities. So we're talking about 100 meters depth, order of magnitude below seafloor. So we're not talking about very deep geological aspects associated with reservoir geology, drilling geohazards, carbon capture and storage, and nuclear waste disposal. They are considered to be outside the scope of this report. We're very much focusing on the shallow geology associated with facilities, the foundation zone, and very shallow geomorphology associated with cables and pipelines and geohazards in that zone. So it's very much focused on the shallow geology. In terms of the water depth, we decided to bound this at a nominal water depth of 10 meters, Again, that's sort of order of magnitude 10 meters rather than a very hard, 9.9's out and 10.1 is in. But it's really sort of reflecting change from more of a sort of an onshore site investigation scope to an offshore scope, with a change of reliance on geophysics, different types of vessels that less than 10 meters, very much in the sort of jack-up or barge-mounted equipment and surveys. Whereas for the deeper water, we're talking about larger vessels. But it's not a hard cut-off. But we have said everything less than 10 meters outside the scope of this working party, but that will be picked up by the coastal and nearshore working party, which we'll be talking to next month, which is very much focused on the shallow water. So that is a separate working party, or is a proposed working party, but we are hoping to provide that back-to-back coverage with very consistent approach between the two. At the other end of the spectrum, there's no maximum water depth being defined. So we're going as deep as it takes, but obviously that will have an impact on the types of engineering facilities that will be designing those zones. And I think just the final note really around just a recognition that we do recognise that the quality of the final publication will be contingent on data sets from industrial sources. As I say, traditionally, sort of offshore hydrocarbon renewable operators have been quite guarded about their data. There is some excellent public domain information with the likes of the BGS and NOC, and more data becoming publicly available. But we're obviously keen to tap into a lot of that sort of private sector work, which, as I say, may have been difficult to access historically, but that may have an impact on the sort of the quality of the images and the practical case studies that we can share in the final publication. So just moving on to who's involved with the working party. So we've got 4 officers, which we're on the call tonight. So as myself as chair, Gareth Carter as secretary, Jim, who's the publishing editor, and Mike, that's the technical editor. So we're the sort of 4 officers that are leading the charge, but it's very much a team effort with the other working party members listed on here. So we've got Andrew Deeks, Brian McKenzie, Andy Mills, Roger Moore, Lorraine O'Leary, and Martin Vanesta. It's very much a team effort from all of the working party members, those 10 people listed. But we have a large number of co-authors as well that are supporting all of us as lead authors, and various contributors that are providing images and case studies and all sorts. So, whilst it's the 10 of us that are driving sort of the management committee, as it were, it's just to recognise the massive amount of support that we receive from the wider community. So I appreciate a number of those are on the call today, so thank you very much for your support. Other things to pick up from the steering group, again, part of our success story was really having people involved in the steering group that then rolled on directly to the working party. So we didn't really lose any momentum when we initiated the working party. So a number of those with the red stars highlighted that were involved with the steering group and developing the scope, plus just recognising other members that didn't carry on with the working party. So Andy Barwise, Dave Giles, Anna Morley, and Steve Thomas. Thanks for your support setting up the working party. We're also endorsed, so we are a working party of the engineering group of the Geological Society, but a number of other committees or affiliated societies are providing support. So just to run through the list, that's the BGA, the British Sedimentological Research Group, BSRG, the Marine Studies Group, and SUTOSIG, so Society for Underwater Technology, Offshore Site Investigation and Geotechnics, Special Interest Group, are all supportive of the publication. So thanks to all of them for their support as we go forwards. Moving on, I'm just going to do a very quick introduction to the table of contents of the report and the lead authors for each of these chapters, and then I'm going to go on and we'll talk through the individual chapters and give you a bit of flavour for the approach and a bit more detail and a few images. So if you've looked at the glacial paraglacial book, you'll see it's actually quite a similar approach, and again that was done on purpose to try and support that style that worked very well. So it's very much the start of the publication is around setting the scene. It's bigger picture, geomorphology and the setting. We have a section of sort of illustrated glossary, which is very much about terms and definitions and standard approaches and key figures and references, so that we sort of use a common language. And again, that was a big driver for the working party, is to try and have a consistent approach and compare and contrast approaches at different industries, different sectors, different operators, but have a single language that we can all use for specific geological features or processes or sediments. We then go into ground modelling, so a sort of broad overview around the ground modelling approach and the sort of onshore analogues, and trying to, again, drive consistency with things like the IAG Commission on ground models. And then we go on to talk about specific offshore ground models, which Michael talked through in a minute. And then we go into more of the sort of how do you actually manage this approach on a project, a typical project. So we sort of about the general site characterization principles and data integration approaches, so led by Andy. And then we've got sort of three chapters really talking about tools and techniques. So we have geophysical approaches by Martin, geotechnical approaches by Brian, and geological approaches by Mike. And then brought together with really what does that mean for engineering, risk management, and design considerations by Andrew. And then a final concluding chapter with some illustrative case studies. So that's the overall. I'm going to go through a bit more detail on some of these now as part of the main body of the presentation. So probably very brief one, but really sort of chapter 1, setting the scene, introduction as to what we're doing, why we're doing it, a bit of a background as to how we've approached the problem, and a bit of a context. We're also introducing a sort of hazard inventory approach and a risk framework throughout the report. So that will be introduced in chapter 1, and then it'll be populated in the subsequent chapters as to how you implement that in practice. And then that will be brought together in the final chapter, chapter 10, as a fully integrated risk framework that drives through the whole process. Chapter 2, so this is led by Roger Moore. Really sort of setting the scene on big picture. So we talk about the offshore setting, the offshore environment, and why it is different and unique compared with the onshore environment. So really talking about the Met Ocean, about the meteorological and oceanographic processes, and the impact of contemporary and historic climate change with impacts on sea level rise. Then talk about the geomorphology and geomorphological setting. And again, there's a framework there developed for how we build from the sort of mesoscale through the micro on a sort of case-by-case basis. So that's the sort of geomorphological framework that's being provided. We then go to talk about a geological framework, looking at, again, starting big picture with sort of plate tectonics and how that drives different tectonic units and settings, and then going through into a stratigraphic framework, and then the final section talking about sediments and sediment sources and processes. And talking about that again from a big picture. So that's chapter 2, on the offshore setting. Chapter 3 is then an illustrated glossary. So it's really about trying to have sort of very standard tools and techniques and nomenclature that we can apply throughout the report. But again, very similar format being proposed, the glacial, paraglacial, where we have typically 1 page per feature. We talk about sort of how we're defining a certain feature in the book. We talk about synonyms for how people may have defined it historically. We have some summary descriptions, some indicative figures, which could be sort of bathymetry, as in the case example here. They could be seismic, they could be core photos, ROV type photos, but trying to have some diagnostic or some typical features, and what those diagnostic criteria are. And then briefly, we talk about the engineering implications for each of those features and key references for further reading. Again, very much a team effort led by Gareth, and just acknowledging the other co-authors in that area at the bottom there. So that's chapter 3. I think at that point, I'm going to hand over to Mike, who's going to talk through chapter 4. The next 3.
Yeah, I think I'm doing my best Chris Whitty, right? I'll just shout slide at you when we need to transition, but you hear me okay?
Yeah, that's good, Mike.
Yeah, I mean, I suspect looking at the attendance list here, we're pretty much preaching to the converted on the approach of what we're doing. So chapter 4 is very much talking about ground models, and most of you will be familiar with ground models, but this is setting the scene particularly for those that aren't aware. And this is really, first of all, looking at the transition from Roger Moore's chapter, which is providing the oceanographic, geological, tectonic context for the oceans and how things vary, processes and features vary at different scales. This next chapter is then trying to put that into the context of a project. So why do we actually care about those different processes or features? What implications may they have to different types of engineering development, different types of structure, for example? So it emphasizes why we need ground models. And in part, this is because particularly for offshore developments, whether it's large, extensive offshore wind farms, it's complex deep water oil and gas developments, or it's extremely long distance power or telecoms cables that might span whole ocean basins. We gather large multidisciplinary data sets that are discussed in the subsequent chapters. And how do we deal with them? How do we integrate those data? And how do we integrate the data as they become successively available and our state of knowledge evolves? So the justification for the ground model type approach is basically sold to deal with those complex data sets, to understand often large areas or long distance projects that may, even in small areas such as areas of previously glaciated continental shelf, feature extremely vertically and laterally variable geology, which might have quite distinct offshore challenges, be that to different types of foundation, different types of structure, or distinct characteristics of the offshore environment and the geology itself. And here we set out the fact that what we're trying to do with the ground model is identify, assess, and mitigate any geohazards and constraints at the earliest stage in the development planning process, to make sure that site surveys and investigations, so this is the geophysical surveys that are non-intrusive, and geotechnical investigations and potentially focused geological investigations are optimized and targeted appropriately, and that we identify engineering opportunities, as has been explained by many previous papers on ground models, particularly offshore, so building on work that Trevor Evans has presented on previously. And then really explaining how the ground model and the accompanying site characterization inventory and geohazard inventory provide an auditable record that can be updated as the state of knowledge and as the project evolves. So next slide, please, Chris. So this is really talking to the translation from Roger's chapter, which outlines, say, processes that happen in the ocean at differing water depths and indeed may occur below the sea, the sea floor, and then starting to relate them to what this may actually mean in terms of impacts, constraints, or potential challenges for offshore developments. So we'll go through a number of examples, and they'll be illustrated, and they're being illustrated with real world examples from actual projects, from various different types of development, from offshore renewables, telecommunications cables, oil and gas, to include aspects such as submarine slope instability and landslides, sediment avalanche, sediment density flows such as turbidity currents that can break cables or impact pipelines, the influence of subsurface and seafloor fluid flow, and then regional seismicity, tectonism, and that tectonism can be related to plate tectonism as well as in relation to glaciotectonism or induced by subsurface salt movement and volcanism. And then mobility of the seafloor sediments, so sediment mobility and potentially scour around structures. And Chris has said that we're limiting the depth below the seafloor to about 100 meters, but that doesn't mean that the depth that we may have to acquire data to doesn't go beyond that. And particularly when we're thinking about seismic sources, active faults, these sorts of things, we may need to extend kilometers below the seafloor in terms of the geophysical imaging and the characterization. We also then focus on ground conditions, and this links in very nicely to Roger's work looking at different types of sediments and variation in sedimentation and processes that have affected different types of margin and basin and slope. So here we're going to focus particularly on conditions that are specific or distinct to the offshore environment. So some things will be similar, and certainly there's lots of crossovers with the previous work of the last publication of the working group. Looking at previously ice-loaded and glaciotectonically modified sediments. And indeed, there are many good onshore analogues, and these will be identified and illustrated throughout this chapter. But also thinking about conditions that are distinct and specific to deep water environments. So extremely low shear strength, high moisture content, low unit weight clays and oozes that typify many deep water settings that accumulate under very low rates of hemipelagic accumulation, looking at specific biological modifications, the effects of bioturbation and the kind of this biological snot, extracellular polymeric substances that can create an initially higher shear strength response, but that can be rapidly lost under loading. The influence of diagenetic modification, the infiltration of hydrocarbons and light gases in the sediment that can change their physical properties. So all these aspects are going to be covered, and we have lots of nice examples of what these sorts of things look like at the seafloor, what they look like in core, and also what their geotechnical response is. Next slide, please, Chris.
It's not playing ball. Sorry.
That's all right. So within the context of this chapter, when we use the phrase ground model, we're using this to basically, explain multiple different types of models. So this spans from a conceptual model, which could be as simple as a cartoon drawing with a pencil, but this will obviously evolve as your state of understanding moves on, and lots of wonderful examples, going back to Peter Fuchs's work. So this is very much building on that. We'll reference observational models and provide several examples of where a ground model type approach has been used successfully on offshore developments. And then discuss analytical models or quantitative ground models that maybe use things like an inversion of geophysical properties to get to quantitative or predictive geotechnical properties that could be used directly in design. So we'll cover all these different aspects. We'll cover the standards governing offshore ground models that currently exist internationally. But we'll also discuss the ground model and how it evolves. And so how it evolves, that's as data become available. And so a state of confidence becomes greater, but the volumes of data also become greater. We need to think about the ground model as site conditions change, recognizing the fact that the seafloor itself and the subsurface can be quite dynamic in many settings. So here, looking at examples of mobile bed forms from a paper by Neil Mitchell from last year in the Bristol Channel. And also recognizing that needs may change. So layout designs may change. And throughout the lifetime of a project, things change. You come towards the end and we're looking at decommissioning of some round one wind farm sites, of oil and gas developments in the North Sea and other places. And indeed, the use of a site may change. A previous hydrocarbon extraction site may be repurposed for carbon capture and storage. So these are the sorts of things that we will think about. And we'll have a number of illustrated examples of different types of setting linking to Roger's chapter. So some of the examples that we'll look at are salt tectonic affected margins, previously glaciated continental shelf, carbonate dominated margins, convergent margins, high latitude fjords, offshore river deltas, and passive margin continental slopes. But obviously, if your favorite margin isn't in there, then wave your hand and we'll make sure you get represented. I think next slide now, Chris. So Andy Mills is leading the charge on chapter 5, which is very much about the kind of the nuts and bolts and the mechanics of how you actually put all these things together. So we've set the scene for why the ocean and the seafloor and subsurface is important, for the different processes and features that operate and exist across different scales, for the need to integrate those data and to understand the site and its history holistically. Now, how do we actually do that? This is Andy's chapter, and emphasizing the need for integrated teams, very much building on work that Dennis Brunsden and others have published on before. So the need for a core geo team that represents geological, geotechnical, geophysical, and multiple other disciplines, but also thinking about the different individuals and teams that engage with that group and that need to be engaged as well, be they environmental, archaeological, deep subsurface hydrocarbon, risk, different aspects of engineering. What are the key technical interfaces? This chapter will cover those bases. And we'll also set out the need and the approach that could be used, and the different approaches that can be used, recognizing that not all projects operate in exactly the same way, but how you might put together an integrated survey and site investigation planning approach. Talk about objectives, so how you might set up a seismostratigraphic model using geophysical data, and then how you might start to develop that model and calibrate it with information that's going to be pertinent and relevant for geotechnical engineering design. We'll discuss how you can phase these types of approaches and some of the challenges that exist in different types of phasing. It's going to talk about data quality. What makes good quality data? What are the challenges in some different settings and on different projects? And what sort of coverage of data you might need for different types of developments. And this is recognizing the fact that we span very narrow corridors where we may be looking at very shallow below seafloor conditions for telecoms or power cable routes, all the way through to much deeper foundations, maybe conductors for the top hole of offshore oil and gas developments. And we'll touch on different aspects of environmental, archaeological and metocean investigations. So this isn't going to be a textbook on those topics, but it does explain the importance of those topics, why you need to consider these factors in planning a development, and also some of the value that you might gain from integrating with those disciplines, sharing data, and using the interpretations from those different workflows to develop the ground model. Next slide, please, Chris. So one key aspect of this is a recognition that we're typically dealing with a huge amount of geospatial data, often lots of individual sampling points, but typically for offshore developments, we're dealing with a lot of remote sense data. So this is, bathymetry data, backscatter data, subsurface geophysical data. How do we put that together? Well, discussing different approaches that exist, but largely how you use geographic information systems, and some of the challenges and opportunities in cross-platform working. So again, this won't be a textbook for how to use ArcGIS or Kingdom Suite, but we'll talk about some of the opportunities and also challenges in integrating data sets between, say, geospatial GIS databases, seismic interpretation software, and then geotechnical databases. And then we'll have some discussion and some worked examples of data interpretation and site characterization inventories. So how do we put together inventories of seafloor and subsurface conditions? And also discussing some of the other aspects that need to be considered within the development planning. So anthropogenic constraints, this could be wrecks, it could be unexploded ordnance, environmental constraints, so sensitive habitats, for example, and then also broadly thinking about spatial constraints, mapping and marine spatial planning at a fairly high level. Next slide, please, Chris. So Martin Van Ester's chapter, so Martin at NGI, he's roped in an excellent team of individuals who have been working hard in trying to then think about specific techniques that are used and the different challenges that they use to provide solutions to. So chapter 6, 7, and 8 are very much techniques-based chapters. You almost could view them as an annex to the volume, that these are not going to be a textbook on what geophysics is or how to interpret geophysical data, but it will explain the different types of tools and methods and approaches that exist for imaging the seabed, the subsurface, and also for monitoring for things like geohazard assessment. And the different stages in the development that they might be used in, the different types of challenge they might be used, the different water depths, and the benefits and pitfalls of different tools. This is going to be extensively illustrated with examples that show how the different tools work and how they're deployed, as well as providing examples of the data that you can get from this. So example shown here, the top right, is multi-beam echo sounder data shown in a 3D perspective view, looking at high amplitude bubbles from gas vents that are being released from the sea floor. And the bottom looking at different types. We'll show different schematics of how different types of seismic or geophysical system are deployed. And this will outline different survey platforms. So not just the tools we use, but how you might deploy them. So whether you're using vessel-based systems, whether these are deployed from autonomous underwater vehicles or surface vessels, or using seabed nodes, or indeed deployed down boreholes. Give a back reference to existing guidelines and standards that exist, so we don't aim to replicate or duplicate anything that already exists. There's plenty of good work going on within SUT and various other fora. We will reference those and not replicate those. And then really get down in the weeds in some geophysical techniques and methods. So starting off with the water column, so we could image gas release from pockmarks, for example, the imaging of the seafloor, the subsurface, and then talking about some of the emerging technologies, which includes novel analysis of geophysical data to predict geotechnical properties, but also things like the use of distributed fiber optic sensing in various different applications. And then finally wrapping up with, when would you use different types of tool, under what conditions, and how do they help you characterize site conditions and assess the geohazards that might exist within a site. Next slide, please, Chris. Yes, so here, it won't be a textbook, but it will cover some fundamental basics, and it's very much aimed to provide new practitioners with an introduction to geophysics if they haven't looked at it before. So it will start talking about the sort of resolution potential of different tools and approaches. So the image on the top right here basically showing under different frequencies what sort of thickness layer you might actually be able to resolve. It will then cover some more advanced aspects of geophysics as well, things like full waveform inversion and links between seismic parameters and geotechnical properties. So the bottom left here showing information how we might be able to list the speed of waves versus the undrained shear strength of sediments and start to get to predictive quantitative relationships. Next slide, please. And within this will link into the geohazards that are referenced in the ground models chapter, and particularly thinking about subsurface geohazards such as shallow gas, elevated pore pressure that might be challenges for drilling or installation of deep foundations, things that may provide a constraint to all sorts of foundations or to trenching of cables such as boulders, but particularly how we use geophysical tools to characterize spatial variability and to allow a confident extrapolation between point geotechnical locations. And we'll specifically then talk about the different types of surveys, the scales, the specification, the types of equipment that you might use for surveying an oil and gas rig site, a cable route, a large offshore wind development that you might need for decommissioning, for ecological, archaeological surveys, or deep sea mining projects. So this will span the full range of water depths, going all the way down to full ocean depth, because cables, deep sea mining are routinely now being proposed in ultra deep water. Next slide, Chris. So chapter 7 is another methods chapter. So this is very much focused on marine geotechnical investigation and interpretation. So Brian McKenzie is leading this chapter with Lorraine O'Leary. And so here is the aim is to provide a background to the origins and history of marine geotechnical investigations. This will also set the scene for how and why the tools are very different, although sometimes can be quite similar to those that are used onshore. And provide some background, really focusing on technical aspects, but how you might set up, plan, and contract a geotechnical investigation, and then in more detail, how you would actually execute that. So the different elements that are involved in terms of mobilization, field work, laboratory schedule and testing, and then the data interpretation and reporting elements. Next slide, please. So the real guts of this chapter are going to be in the equipment and methods. So this is, why would you select different tools? What sort of platforms are used and how might you deploy and can you deploy different tools? So similar to Martin's chapter, this will talk about operations offshore from drilling vessels or vessels of opportunity, or indeed other platforms. The sorts of work that you might do via downhole testing or via different methods. And introduce sampling and geophysical logging tools. Talk specifically about rock coring, as this may come up on a case-by-case basis, and then some detailed discussion on seabed testing and sampling, so cone penetration testing and the like, and advances in seabed drilling that don't necessarily rely on use of a drilling vessel. It will then touch on some of the future trends and innovations, just so we don't make sure that the book is sufficiently future-proofed, and then some discussions on marine soil rock logging, and then testing. So what sort of testing can be done, what how would you develop a laboratory testing strategy for different types of development? And how do you interpret those data and parameterize the conditions so that you can use the information you've gathered for robust design purposes? Next slide. So the final methods chapter is focused on geological testing and analysis. And this is really kind of on a case-by-case basis. So whilst you would always perform geophysical surveys and you're always going to gather data for geotechnical design, this chapter is very much looking at bespoke cases where the ground model and the geohazard inventory or the site characterization inventory have identified there's a specific need to gain more information. So this touches on aspects of detailed geological identification of deposits, for example, and characterization of mineralogical or geochemical information, getting an age framework for the past depositional history of a site, or thinking about specialist geological studies that might be needed. So in essence, we're really asking fundamental questions that are raised from the ground model compilation. And this is to help with a number of different things, where maybe we need enhanced calibration of the geophysical interpretation. It may be very subjective, and it may be important to discern whether we're looking at a debris flow deposit or just background hemipelagic deposits. We may sometimes get apparently anomalous geotechnical results, and so an understanding of various different aspects of the geological of a history of a site might help us understand that. So maybe it's had a variable or complicated loading history. To inform the geohazard assessment, so maybe we need to understand information on frequency and magnitude of events. We want to understand the provenance or the source of different mass flow deposits, and so the geochemistry of the deposits will help, but ultimately to update and provide extra confidence in the ground model. So next slide, please, Chris. So this will be illustrated with lots of examples of where these kind of bespoke techniques have been developed and used on individual projects, such as detailed sedimentological core logging to calibrate geophysical signatures to understand different types of mass movement and their potential risks for offshore pipelines or deep sea developments, to identify specifically the location of failure planes, to explain anomalous geotechnical test results, geochronological or biostratigraphic analysis to provide a depositional chronology for a site. And yeah, so it's really kind of bringing in some fairly specific, or in some cases quite niche, geological analytical techniques, and just explaining how these could be used to answer questions, but how this is going to be dictated by the geo team and the needs of the ground model. So next slide, please, Chris. Yeah, jump along. Yeah, so I think you're picking up from here. Is that right?
Right, yeah, can you hear me okay?
Yeah.
Fantastic. No, that's brilliant, Mike. Thank you very much. Yeah, so I'll just bring the presentation, sort of the last couple of chapters. So chapter 9, this is Andrew Deeks leading on this chapter, really sort of bring it all together in terms of, you know, how does this site characterization, what does it mean in practice? You know, so what? You know, how do I use it for a real facility? So really talking about sort of engineering risk management approaches and how we characterize the risk. And also design considerations, you know, what does that mean for designing facilities in the offshore environment? So obviously setting the scene initially, talking about the different types of projects that we will cover as part of the publication, and obviously, you know, comparing and contrasting. Obviously very different sort of offshore wind and hydrocarbons, but there are similarities, there are significant differences as well as things like waste storage and cables, pipes and the like, so pipelines. Andrew will then talk about the engineering risk management approach, so how you assess, how you mitigate, and how that feeds through the design process. And then what does that mean in practice with layout optimization and design assessment, different tools and approaches. The entire thing illustrated with a number of sort of case studies throughout. I think the important point to make here, I think very similar to what Mike said about the previous 3 techniques chapters, we're not looking to repeat codes and standards that are already out there, very relevant for the tools and techniques and, site characterization tools, but also for engineering design. So we won't tell you how to design a pile in certain conditions, but we will point out, we will cross-reference the different design approaches that already exist, and maybe more of the sort of qualitative approach as to when certain things do work well and when they don't work well. So that's sort of support to a potential designer. And obviously it's very important for, for practicing engineering geologists, geotechnical engineers to be aware of the different types of structures and foundations that are available to them, and therefore what site investigations do they need and how will that drive that decision making. So that's what we're trying to pull together in this sort of final closing chapter. But the last chapter of the book, so this will be the sort of conclusions, bringing the whole publication to a close, with some key conclusions, key approaches drawn out from across the publication, and some key illustrative case studies, sort of success stories of where it's been applied in practice, either in real situations or potentially we're thinking about some synthetic situations, to just demonstrate the case of how to apply the book. And then I think I touched on at the start, we're also having this hazard inventory approach, which we'll introduce very, very early on in chapter 1. We'll then populate it through the different chapters and say how you might design a geophysical limit survey, a geotechnical investigation, geological tools, engineering mitigations that you may put in place. But we'll look to consolidate that whole approach in the concluding chapter, the last chapter 10. So that's sort of drawing to a close the book. In terms of where we're at in terms of the working party and what the aims are going forward. If you're repeating what I said at the start, but we're aiming for substantive completion of all report chapters by the end of this year. We go through a very rigorous review process. So as working party members, so we have the 10 key members that are all lead authors and co-authors, but predominantly sort of lead authors and officers. We have a responsibility to review all of the chapters. So a lead author for one chapter will review all of the other chapters. So we have this consistent style of approach through the book. So a very rigorous internal peer review, and obviously very important to look for gaps and overlaps and really just sort of any consistency checks. So we make sure we're using the same language throughout. So as well as the internal review that all of the chapters go through, we also have an independent external review. So that's somebody that's not been involved with drafting the publication, but just a fresh pair of eyes. And that's a very useful process. So that is ongoing. We go through, we finish the chapter, we do an internal review, we do an external review, and obviously final edits being made throughout that course. So that's ongoing at the moment, and looking for complete publication by then 23. I think the only other point I'd add at this time, we've had a bit of pressure from publishing house to be publishing chapters as they're complete. So once they're complete, as I say, our first chapter is now complete. That's been internally and externally reviewed. But our preference is that we will wait until all of the chapters are complete so we can make sure we've got absolute consistency between the lot before we publish everything, hopefully next year. But that will be published as a single volume, but with chapters that you can download independently. So I said we're getting pretty close. We're making really good progress. There's still a few gaps to fill. So, particularly we're looking for things like case studies, some great case studies, either pre-published, either very old historic case studies that people have forgotten about, or any new novel case studies that you think are areas that will be useful. As well as illustrations, we're always looking for high quality, photo glossary contributions and contributors, people that have got an interest in helping to draft that. So please get in touch. Our contact details are at the bottom there, but please just drop us a line if you've got any interest or case studies, images that you'd like to share with us. We're also going through the process of appointing external reviewers as well. So we have some ideas and we have approached people as the chapters become ready. But again, any suggestions we welcome in that respect. So as we draw to a close, we'll be looking to hold some sort of one-day launch seminar, a book launch, where a bit more detail, just talk through each of the chapters in line. So either late this year or early next year, we'll keep you updated through the engineering group on that. And then once the book is actually launched, we're planning for a series of dissemination events. So we normally hold sort of central events and regional events. We'll look to international conferences and the like to be presenting at those, just to try and get out there as widely as possible. And then also building on the success of the Geohazards working party recently, we're also considering running CPD courses. So there might be sort of dedicated training courses for some of the key chapters, some of the key areas. So more of an interactive sort of classroom-led approach on, more sort of training approach for the working party. So again, that will all follow, next year. And then finally, just a plug for the coastal and nearshore steering group as it is at the moment, but we're hoping that that will move forward into a working party in sort of middle of this year, provided it gets support from the wider community and from the publishing house and the like. So I would ask you, if you're interested, please do come along to our presentation the 11th of May. Very similar format to tonight, but a different context. So that'd be great to be able to discuss that with you. And I think that's reached the end. Both my own and Gareth's contact details at the bottom there, so please do drop us a line with any queries. But I think that's the end of the presentation as such. Happy to go to any Q&A. So I think what I'll do, I'm just going to have a look on the chat and something come in, but please stick your hand up. No, any questions?
Unmute themselves. More than happy to do that at this point. If anyone's got any questions.
You say we're happy to share the PDF, Chris, right, of the presentation?
Yes, yeah. Absolutely. Right, okay, I'm going to stop sharing just so I can see who's on the participants. That's okay. And a couple of hands gone up already. So I can see Tim first.
Hi, thanks. Very interesting. Thanks very much. I was involved in a lot of offshore work some time ago, and one of the big issues, and I don't know if you are covering it or have covered it, is really the sort of technical issues to do with the environment, the weather, the depth, water pressure, tides, waves, etc. And I just wonder whether there's any part of that which is going to be in the book, because that can be the largest problem when working offshore.
Absolutely, yeah. I certainly endorse that from personal experience as well. So just to clarify, when you talk about environment, you're talking about the maritime environment and working conditions rather than sort of flora and fauna and biodiversity and the like. But yeah, we are covering both to a greater or lesser degree. So very much part of Andy Mills' chapter talking about integrated site investigation campaigns and that data integration, but very much talking about the practicalities of commissioning campaigns. Again, massive benefits in being integrated campaigns, that you're not going out with a single discipline on every single different missions, that you're combining geophysical, environmental, geotechnical campaigns through that, and very much talking about the practicalities of how to arrange that, how to use historic metocean criteria to work out the optimum time for campaigns, how much sort of standing time and waiting on weather to account for in different times of the year, different environments. So yeah, that's very much part of that chapter.
And the other thing is, the sort of vehicles that one can use, ships or platforms or jackups or crane barges, etc.
Yes.
I think there's obviously a lot of choice there, and sort of certain vehicles are better than others for certain types of work.
Yeah. Absolutely. Yeah. So that'll be covered. So that's all in terms of working platforms. Again, whether you have a dedicated survey vessel that does that thing day in, day out, or vessels of opportunity that you're mobilizing and spread onto, or as you say, drilling rigs and jackup rigs that you might use for doing geotechnical investigation in certain situations. So I think we do talk to those various platforms.
And the second thing is, are you going to include case histories where perhaps things have not gone to plan?
Yeah.
I can mention several where because of the difficulties of site investigation, the geotechnical work had to be completely redesigned, even after the start of installation.
Yeah. And
I'm just thinking of some cases that I was involved with. I mean, not my fault, but and sometimes that's a huge cost.
Yeah.
And are there going to be any sort of case histories that could be learned from?
Absolutely, yes. So that is the intention. We will have a number of case studies throughout the book, trying to draw on those positive experiences and those sort of lessons learned from when things haven't gone so well. Again, this would be a request to everyone on the call, but if yourself, Tim, if you've got any specifics that you're happy to share, as I say, from past experience, and it's not just the offshore environment, but we're very good at publishing success stories, and when they've gone well, it's very difficult to share those stories. They're not necessarily in the public domain because they've generally got contractual issues and claims, and the clients or the operators want to keep them under wraps. So if you've got examples you are prepared to talk about, or you've got access, or where they're published elsewhere, then we'd very happily receive them and publish them. So that would be the intention. We'd love to be able to do that. But as I say, it's and maybe a bit sort of analog with the onshore environment. I think the onshore, there's a lot of published stuff about big geotechnical failures, big landslides, big tsunamis, big issues that have been published. They're in the public domain. But I think when you're talking about offshore environment, it's a lot more protective in terms of traditionally through the oil and gas operators are very guarded about their keeping their commercial edge and not necessarily sharing their risks and publishing their risk widely. So I think it's much harder in the offshore domain than the onshore. So
absolutely.
Very grateful for your own or any other contributions that very happy
I don't
to
want to be
receive.
sued.
No, exactly.
It's a very good point, and they are very useful examples. So fortunately, we do have a number of them. It's either lessons learned. Examples of, say, taking foundation designs that were originally conceived for the North Sea and the Gulf of Mexico, and then the move into Northwest Shelf Australia, where you have a carbonate dominated system, and those pile designs simply don't apply, and so there's changes. So those sorts of aspects are quite well published on, but many of the individual specific elements aren't. So where we can't drill into a specific case study, we're still going to highlight areas where there is experience within the industry that's known, and then relate that to different types of ground conditions, different environmental settings, and think about where else it might apply to. And examples about offshore wind farm sites where the field, the layout has had to fundamentally change because of late stage identification of obstructions to foundations. And with regard to your first point, I think that will actually permeate the whole volume. So whilst this isn't a review of metocean conditions offshore, Roger Moore's chapter will be talking about various different types of oceanographic conditions that exist. So, the wind, waves, tides, all those things, but local specifics such as solitons and internal waves that might be trapped by local topography. That then links into things like scour and sediment mobility. Andy Mills's chapter will also focus on, not in a lot of detail, but how you might need to design a riser to withstand currents that operate within the water column. Martin Van Ester's chapter on geophysics will explain how different weather conditions may adversely affect the quality of the geophysical data you get. Brian's chapter on how different weather conditions might prohibit you from taking certain types of geotechnical data. So it's going to be in there, but it's not going to be at the core of it because it's about ground conditions and geology, and it can keep growing. But as you say, offshore, the sea is something you've got to be pretty aware of.
Okay, thank you.
Thank you, Tim. We've got two more questions that have come through. We've got one from Christian. Are there any plans to include examples of geotechnical properties and behaviour and selection of design parameters to complement the geological parts of the publication?
Yes, there are, and I think it's a very important thing that it doesn't end up being a publication written solely by geologists for geologists and ignore the engineering bit. So probably what's not massively clear at the moment is, so I guess the temptation for people like me who like geohazards is to focus on the landslides and that side of things. Most of what we're doing in an offshore development is really trying to characterize ground conditions, is to try and provide a robust engineering design. And so particularly in Brian Mackenzie's chapter, there is going to be specific text and discussion on selection of design parameters, specification of the laboratory or in situ testing, how you want to get to them, and why you might be doing different tests, or you might need a slightly different investigation and testing schedule for different types of foundation design, different projects. So that will definitely complement the publication. And I maybe glossed through that, so apologies if I've underrepresented Brian's contribution.
Great, and then you've got another question, Mike, from Jordan Wilson.
You discussed the geohazard inventories as part of your various chapters. As part of these inventories, do you discuss ways of quantifying risks offshore, or do they act more as a way of discussing and summarising types of offshore?
Is a good question, and so hopefully, I think, as Chris has said, the concept of a risk register and the approach taken to risk assessment will be defined in chapter 1, and so we will populate an inventory as we go through the volume, and we're quite keen to be clear that we separate what we mean by hazard and risk. And so the whole thing is building up to risk to the point in which we have an understanding of the likelihood and the consequence combined. So in the ground model chapter, we'll introduce geohazard inventories. And so this is a way of identifying the different types of geohazard or adverse ground conditions that we have. As we go through the volume, then we'll start actually putting numbers on that in terms of what this means for likelihood and for consequence. So hopefully that will be illustrated as we go through, but that inventory is something that we're currently populating now to make sure that there is a flow throughout the volume, and that it's as wide-reaching as possible.
So Mike, Sean Pearce has then gone on to say, it's a question or suggestion. It'd be good to align the ground models chapter with the IAEG Commission 25 document, which mandates the use of conceptual, then observational, then analytical, with iteration during the transition from the conceptual to observational. Can this be incorporated?
Of course it can, Sean.
Yeah.
So so Jim Griffiths has put, I don't know if you're on or want to talk to it, Jim, but Jim's put together some nice text in that particular chapter. I see he's there, I think, referencing the different use of ground model in different standards and different approaches, particularly onshore. We are very much discussing that and advocating that approach from conceptual to observational to analytical approach. But I don't know, Jim, do you want to talk a bit more to that?
Yeah, just to say that I'm actually on the IAG Commission 25. So I'm providing the link between both this working party and the Commission 25. I would say that I'm in some debate with Commission 25 about the way they actually describe ground models, but that would be expected, I think, in our kind of profession. But Mike's right. What we have is we have a well-established sequence of for onshore ground models. That's quite well defined. What we haven't really been able to do is to take that yet into the offshore environment. When you look at the literature on models or ground models in the offshore environment, it's very much along the concept of sort of site characterization in broad terms. So the answer to the question is yes, we are going to be working with the Commission 25 model. However, Mike and I have discussed about the developments from that, which we feel are more appropriate in these conditions. I hope that answers the question.
Yeah, I guess this publication is not mandating anything here, but it is providing options to people for what they can use and trying to highlight the existing standards and approaches that exist. But from I guess a simplistic standpoint, we start with the concept, you gather some observational data, and you come up with an analytical model. So that's the type of approach that we're discussing.
Yeah, just to add to that. Yeah, so I think that again, one of the key parts of the working party, we're trying to drive that consistent approach where we can, but also it's that compare and contrast. So one approach may be to call it this, we're going to call it this, somebody else calls it that. So I think that's what we're trying to do, is provide that translatory framework, as it were, that you can go from one to the other. I was just going to pull in, I don't know if it would potentially derail the whole evening, but I noticed that Dave Norbury is on the line and gave us a great presentation on the weekend at the Engineering Group Conference around the Eurocodes and the new Eurocode approach, which doesn't necessarily concord with IAG 25. So again, we are acknowledging it, we are aware of it, it's predominantly onshore. We'll make comparisons where we can, but I think it's not within our remit to try and drive global consistency onshore and offshore and everything, but just to make people aware of that.
That's fabulous. Thank you, everybody. We have run over slightly from what we planned, but I think those are all really important questions that I think are important to address. And kind of, if anybody's got any more, yes, Chris, do you want to get your slides back up? Or should we just say, if you want to contact Chris or you've got any further questions or discussion points, I think that'd be really useful for the working group. And just to reiterate that the next presentation is going to be for the nearshore, and that's it's the 11th of, I wrote it down and then I've lost that little bit. So yes, it's the 11th of May, isn't it, Chris?
That's right.
Yeah.
That's my understanding. Yep.
Yeah, so invites will be going out for that one shortly. So if you found this interesting, or if you're kind of want to get more involved as it gets going, the coastal and nearshore one, that'd be really good to see everybody come along to that one, I think. So if you got anything else to say, Chris, or you're happy?
No, I think that's fantastic. So yeah, thanks everyone for the feedback, the contributions. I think just to acknowledge, thanks to Mike for presenting, but obviously we're part of a much larger working party. So the 10 of us that have been driving this, as well as numerous co-authors, contributors. So that's fantastic. I think actually the only thing I probably should have mentioned as part of the close, we'll be looking to obviously close out the book, and there's a lot of topic entailing. We're looking to try and get in the industry support in the form of sponsorship. The main aim for that, historically, it's been to support colour printing of the publication. Colour printing is now provided as standard, but we are looking to still seek that sponsorship, mainly so that we can bring the sort of list price of the book down. We can make it as cheap as possible for people to buy the book, which obviously will increase the outtake by the community. So we will be going out to the community soon to seek sponsorship. So just a final plug there that I'll be in touch in due course. But,
that's perfect. Thanks everybody for joining. Have a wonderful rest of your evening, and thanks again to our presenters. It was a really interesting presentation and great questions at the end. Enjoy everyone. Have a good evening, and see you hopefully in a month.
Thanks. Bye.
Thanks.